Hello everyone, welcome to visit ODOT live stream. This is Raphael. Nice to meet you.
Hello everyone, I'm 11. Nice to meet you.
Okay, 11. So we ODOT Automation. We are a company focused on industry internet transmission solutions. So we have solutions like I/O modules, switches, converters. But do you know when do we start our business?
Wow, it's a long history. In 2003, Mr. Kevin Wang founded our company.
Okay, so next year will be our 20 years anniversary for our company.
Yeah, that's right.
Wow. So can you share us some details about dot automation when it's beginning?
Oh, as I know, in the beginning, we are a project-oriented company. From 2003 and to 2015, we always do projects. At that time, we have many projects. As time goes by, the profit margin becomes narrow, and we need to purchase branded products like Siemens, because the product is very expensive, so we can't make more money. Then in 2013, we started to research and development our own products. Then in 2015 or 13, our first protocol converter developed, right?
Yes, at that time, because in the first we are project company, but we have almost 10 years, almost 10 years of experience at that time, and we have built a team for engineers. So because of the disadvantages caused by the high prices for the products, for the branded products, we have organized our engineers to build our R&D center. So with the R&D center, with the experience from the projects, we build our products. So just like 11 said, we build our first protocol converters, the PROFIBUS-DP converter in 2013, and then for 2018 we have our AI box, and in 2019 we started with our remote I/O modules. So it looks almost we have all the solution for the other users. But Eleven, do you know if we have our PLCs? Do you have any information?
Oh yes, this year we launched our first version of PLCs. The module number is CP9131. This PLC can realize some simple controls, and now we are upgrading this version. We will do much better in future.
Yes, as you can see, this is our first version for the PLCs. This is a very simple version of PLC because we adults always build things from the simple, and then we move to the complex. So if you are interested to wear our PLCs, please scan our QR code or visit our email to our sales odotautomation.com for more inquiries.
Yes, in our website, you can download our user manual and IO config software and the GSD files, and you can get all the files are free.
Yes. So before the PLC, we have our most sold products in the year of 2022. This is our remote I/O system. So 11, can you introduce us some details about our IOs?
Yeah, this is our PROFIBUS products. This is a distributed I/O system. It can use freely. We can see this is our blade I/O module. It is very thin. The thickness only 14 millimeters, and the length is 110 millimeters, and the width is 75 millimeters. And this is our adapter. We have this one is ProfiNet. We also have PROFIBUS-DP, Modbus RTU, Modbus TCP, can open Ethernet IP.
Yes. But which one is our best sold IO adapters this year?
Yeah. You mean hot selling product?
Yes.
It is this one, CN-8032-L. So today we will give you a demonstration.
Yes. For this one is like the pearls of the crown of the ODOT products family, the CN-8032-L, the ProfiNet adapter. As you can see, we have the LED state indicators above. So each channel of the status could be viewed by the engineers inside. And also below are these wirings, hardware for each site requirements. Also, you can hear this clear click. This is a safety barker. When the engineer inside, once you have heard this invoice, that means the adapters has been fastened on the DIN safety. So this is what we improve at this point. And also, 11, do you know what is this for? This is harness.
This one is a smart design. We can use this one to tie our cables here and make the wiring very tidy and looks pretty.
Oh, that's nice, because sometimes it's the most horrible thing that you have a mess of all the wirings.
Yeah.
That's really very hard for the maintenance.
If without this harness, the cable will look like a mess.
Yes, and also we also have the gold fingers. The above are the gold fingers with the system power and also for the data transmission. And below are the gold fingers for the field powers.
Yeah.
For the wirings. So we have the CAN bus back plates, which could support a very fast speed with our gold finger, with our design, and also how many IO modules we could carry for each adapter?
Each adapter can carry 32 IO modules. Each module the maximum is 16 channels. So our IO solutions can solve 512 data points.
Right. So if you have a big project and it need a big data collections, so you can use our remote IO modules. So with the 512 data channels for data collection, with our remote IO modules, it could support you for many projects. But in case of you need only small data channels collections in your sites, ODOT also we have designed our box cells. The box cells is just like its name, it's a box. But inside of the box, we have a communication board. One communication board plus 4 slots. Each slot could be carried with one piece of digital input output IO module or analog input output IO module. So with this one, we could be solution because you could switch for the protocols for ProfiNet Modbus TCP can open for this and you change in the communication board and you can use it as a really DIY products for you. Okay, let's back to our remote IO today. We will go to their demo test for our CN-8032-L. It will be tested with the Siemens PLCs. So in this demos, we will meet some issues you might face in your daily operations, but we will let you know how we fix it, and then we would like to support you once you need our support. So you can always connect us by scanning our QR code or visiting our website, leave us a message or email us to our sales ODOT-automation.com. Okay, let's go to and switch to our demo test.
Okay, today we are going to use our CN-8032-L and our IO modules 121F, 1222F, 3238, 4234, and power supply IO modules 7220 and the terminal IO modules 5801.
Okay, so this is a review for our full products, and now we can use after we can access in the TIO portal. We can go online access to check out and update the accessible devices. With this, we can check the PLC devices as well as the ProfiNet adapters in our test. Okay, now, so 11, like what we usually need to do, we can start to make the configuration now for the ProfiNet adapter with the PLCs.
Yeah, first we need to cable. After connect the device, we can find the device. For example, PLC CN-8032.
Hold on, we had some problem. So this is for what?
This is change the permissions. Change the permissions, then we can programming because this is the protection.
Yes, now we have done this. This is important because when you first using ODOT products, ProfiNet IOs, when you meet this problem, please follow our videos to resolve it.
So we are adding our network adapter. If we can't find the network adapter, we need to upload our GSD files. The GSD files can be downloaded from our website www.odotautomation.com.
Okay. Also, you can email to our sales odotautomation.com to ask us for support. Okay, so the GSD file is only an identification file in the TIO portal. Now, we are doing the networking now.
Yeah. I need to connect the network adapter with the PLC.
Yes. Also, here we can see this is the digital input-output module and the analog input-out modules we will test today. Also, you can see we have some special modules for the power module like CN-8032-L and also as the terminal module as 5801.
Yes, 7220 and 5801 will not occupy any slots, so we don't need to configure.
Yes, that's very convenient, and also it will save you one extra slot for the configuration. That means with one adapter, you could carry a total 32 pieces of digital input-output module and analog input-output module. So here we can see we need to make sure each I/O modules are configured one by one in the TIA portal. We please don't leave only empty slots here.
Yes, if there's empty slot, there will cause an error.
Yes, but we left one empty slot after the CT121F just now because that is for the counter functions. We will explain this later.
Yeah, this is because 121F have a sub module for counting.
Yes. Also, as you can see, we need to make sure we need to change the actual address. The actual address could be only changed in the TIA portal.
And
yes.
And we say here is the name of the device or network. It is different from the PLC, but we can solve it later.
Yes, we need to make sure the name of the device same with your site hardware names. Okay, now we are connecting the networking now. Okay.
They report an error.
Okay, well, so this error is the version.
Version is not right.
It's not correct. Yes. So
we will check it.
Okay, let's check it. What is the version?
CPU. We will change the device.
Oh, so we need to change the correct CPU version to fit our test. Because our PLC is 1212C. So we need to change according to the correct version for this time.
We try again.
Yes, now
it's loading.
Yes, it's loading.
Stop all the modules and upgrade.
Yes, please follow our instructions by the video. If you meet this kind of problem.
Let's see the status.
Okay. So because just now we changed the versions, and now we found the BF LED status. That means the connection and of the ProfiNet adapter has already connected with the PLCs. The Ethernet connection is okay, but the ProfiNet communication is not okay. So we need to make sure that the name of the devices could be reassigned to same with the configuration hardwares.
Now we changed the names, and we can see the PLC works.
Yes.
But here some modules are not.
Yes,
right.
We have some modules have some errors. It's the configuration have some issues. So we will have a check now.
Because we didn't wiring. So
yes, for the filter parts to these wirings, because each time when you make the test, make sure the wiring for the field powers has been done.
Yeah, needs wiring.
Yes, because we have the connections between the adapter with the PLC has been successfully, but there is no powers for the wiring, so there will be no output. We cannot test it by the TIA portals.
Okay.
Now we finish the wiring, and then we will power on.
Again we will
yes.
try.
Okay, let's go online.
Wow, works.
Yes, it's now back to online. Everything looks fine. And so what we next do, we will programming. We make some simple programming and make demos to show each functions of our modules. So as you can see, the 121F just now we mentioned have the extra nodes.
Yeah, sub-modules for counting.
Yes, this counter, please note, this counter function, counter submodule should not support the frequency.
The frequency can't be bigger than 200 hertz.
Yes, 200 cannot be bigger than 200 megahertz. That is important. And for the 16 digital inputs, each DI has been related to one address. So we can state it could be triggered to support the single edge triggering, double edge triggering, or supports ascending triggering or descending triggering. Also, the outputs to control, you can by input the value 1 by zeroing it. So now we are also looking for the analog
input module.
Yes, for
3238, we can enable and disable the channel.
Yes. So for all the 8 channels, we have a data refresh period of 28 milliseconds.
Yeah. If we close 7 channel and only leave 1 channel, the refreshing speed will be faster.
Yes. This will make sure the module have a refresh period speed to the fastest if you close 7. But if you only close one of the channel, it will reduce the refresh period by 4 milliseconds.
Now we are changing the filter level.
Yes, this filter function, filter levels are the new functions we added to our IOs. Suppose you have some interference in your sites. We can use these filter functions to make sure the communication is stable.
Yes. If the level is higher, the filtration ability is strong, but the speed will be lower.
Yes. So today our test is mostly like we test how the filter levels will affect the speed of our IOs. When you increase the filter levels, like you see, we have 1 to 10 levels, and the speed of the transmission will be slower.
Yeah. Here
so we can set the different levels for different channels.
Now we are setting the 22F digital output modules.
Yes, the output, well, it has the special model and the standard model. So for the standard models, it's suppose it's suppose 4 to 20 minimal ampere, but its conversion will be to 0 to 27648. But if you use special module, the conversion were to 002326768. And also we can change the big-ended and small-ended, higher or lower bytes could be adjusted. So you can see we can increase the level
filtering time.
Yes.
This filtering time is used for anti-interference. Because we connect to the relay, they may cause some interrupts.
Yes, because when connecting relay, there will be a voltage shock.
Yeah.
Yes, lasts for a small period, like almost 2 milliseconds. If no filter, the digital input will receive multiple high-level signals. So this will generate the inference. So if this is a transistor, we don't need a filter because the pulse is stable. Just like now the default is 10. If needed to improve response time, we can change it to 0 or 1.
Yeah. Now let's configure and upload our configuration.
Yes, we can start the demos. We can suppose now we are doing a test by wiring the digital output module, the 222F, to the digital input module, CT121F. So we can keep on triggering for the digital output. Just in the video, we do the test. We triggering on by wiring the digital output module to the digital input module. Yes.
After connection, it will show.
Yes, we can keep on sending the data to test. You can see how it's changed by the monitors by TI portal. Okay, now we do some programming, and we use it like 100 milliseconds.
Second time 100 milliseconds.
Okay, now the address. We come to the programming. This is the default tank table. We will set the address from the beginning of 1.
Yeah, we will define 1 at the beginning.
Yes, 1.00. Then we change it one by one. It's very easy for operating this in the TI portal. Okay, we set the address. And also, currently we are setting the address for the digital modules. As you can see, the digital input has a counter function.
Yeah, we need to define a start point.
Yes, this is we will input for the W84.
And we will set a stop.
This is a reset. This is a reset, so you can zero it by enforce the value. Okay, here we can also create the analog, programming the analog details. Just same like the digital input outputs.
Yeah, we have.
Okay. Okay, so for the details, please follow our instructions by this video, or you can also review with our other videos on our YouTube. And also you can also email to us, to our sales@odotautomation.com to send us the support you need. Okay, just now we also have, you can see the analog has Q address and I address. The I address is for diagnosis, so you can check for the current channel status.
Now we are programming.
Yes, so this is repeat the channels from 1 to 001 to monitor the status. Because we have made a test from the digital output to digital input. Okay, let's keep on doing this.
And programming for our analog module.
Okay, now we write to check if analog status has been changed. We need to make sure when you program according you make this test, follow our instructions on the videos, and you can repeat our demo test in your office or in your lab. And if you have any suggestions, you are warmly welcome to write an email to our sales@odotautomation.com or scan our QR code to find the answers. We will be very glad to support you, and your feedback will be precious and appreciated. Okay, now we almost finish the configurations. Okay, so now the configuration has been finished.
So we can download to our devices.
Yes, don't forget the download. This is very important after you make the configuration. Now the configuration has been downloaded successfully. Let's check what will happen.
Let's see the result.
Oh, so 11 we can see there's some issues. The CT222F has no output because the field power has no wiring. So we need to wiring the field powers.
Yes. Let's see how to do it.
Yes. So just like we mentioned just before, we need to check the wirings when you make the test, or this is very important when you're doing the site applications with our adapters with the PLCs. Make sure you have configured in the TI portal, and also you have already make the wirings correctly.
Yes, that is very important. Programming and connecting is important.
Yes, because if you input some value and the monitor of the status has no change, so you need to go back and check your device wiring if it is correct. So now the engineer are doing the wiring now.
Let's wait a minute. We can see the wiring is very simple.
Yes, also you can check on our user manuals for the wiring. Okay, now we can see the monitor. We can see the monitor for the variable table. Okay, so we can see the data keeps on coming.
Yeah, it's increasing the number.
Yes, but also put in notes, the counters we haven't added it. So we need to check the counters, because you know for the 121F, the 16 inputs, the counters is a very special functions, and also very useful functions as the 16 PNP digital inputs. Now we are checking the counts. Okay, we need to do some programming for the counters. Okay, almost done. Okay, now we can see the counter has been counted. Eleven, can you see how many it has been counted?
It's more than 800.
Yes, we have been counted more than 800 times. Now we force the value. So we continue the test by checking the value status by the digital outputs wiring to the digital inputs. We can check, because just as we mentioned for the filter times, if you increase the filter time, and the speed for the modules will be slow in some extreme environments, but usually for the stables, the filter times, no need for changing it to a high level.
Yeah, the level is higher, the speed is lower. So if you need the speed higher, so the
yes,
level should be lower.
Now we enforce the value 1 in the monitor. We can monitor it. So because for the edge triggering, we can only trigger 0 for one time. So now it starts to reconnect. Now we just programming just now. As you can see, the QW1 will counter. This is to check the performance for the filters, just like say the filter levels.
Yeah, we are checking the filter levels to see if it works, yes, and the speed is different.
Yes, that's why we can wire different input channels to see different filters. like the IW68, we can see different preference to have the different effects. Because the same digital output varying to different DIs, this will have different effects. This is for the transistors. If you are using the transistors, you can use the test like this. Now we can check our devices, because we also have a relay output. The relay output has bigger currents. Also, just as we mentioned, for ODOT extended I/O modules, we also have special I/Os, just like the CT-7220.
7220, 7221, 5801.
Okay, so what's the difference between 7220 and 7221?
7220 and 7221 both are power supply I/O modules, but the difference is 7221 were occupied and not, and 7220 were never occupied, was not.
Oh, that's very nice, because this could make sure all the adapter could carry the maximum of 32 pieces of I/O modules. And also please make sure the system voltage and the adapter must be same source for the power modules. And the filter voltage could be separated. When you increase 7220, it will increase 2000 milliamperes. And now we put back to the TIA portal. We can see the data keeps on increasing.
Yes, it increased faster.
Also, we can reset it. We can add the variable to the monitor table in force 1. This is the CT-121F counter function. Just like what we test wiring by the hardwares. Okay, now we can check the analog filters too. We can wire the analog inputs for the 3238 to the analog output module 4234. We can wire this analog output to analog inputs, also to test the filter functions.
Yes, different channel, different filtering level, and different speed.
Yes, we can see. Now the values keeps on changing. If the filter never changes, the more stronger the filter level will make the delays will be slow.
That's it.
Okay, just for the because for the error configuration, we have error configuration software. No need to configure the 7220 and also for the 5801. For the adapter, no need to configure it.
Yeah, 5801 is terminal I/O module. With this I/O module, it will make our system work stably.
Okay, so the videos has been finished. We have already gone through the demo test for the ODOT ProfiNet IO module, the CN-8032-L. The test with the Siemens PLCs. In this video, you have already seen the problem we met will meet during the daily operations. So please follow our instructions in the video to resolve these problems. But 11, some other issues we might meet.
Maybe after power off, you can send the device name.
Oh, this is a very big problem because we have some end users his engineer, he has configured the device name in the TIO portal, and then he power off and power on, and he found the name has been back. He cannot change it because this is mainly because the issues we have a PIP switch here.
Yeah, the deep switch must turn on. So when the power off, it will back to the switch.
Yes. When you're using our ODOT adapters, if the DIP switches has been turned to on, that means the assigned name will be decided by the DIP switches. So if you need to configure the device name by TIA portal, we suggest to
turn off the switches.
Yes, turn off. Make sure all these switches are being turned off, and then you can configure the name in the TIA portal again. And also, secondly, please make sure our IO modules could be connected correctly because we have the gold fingers.
Yeah, the gold finger is very tiny.
Yes, so we need to make sure it has been connected correctly so the transmissions could be done, and also the powers could be wired to each modules one by one by the gold fingers on each IOs. And also for the ODOT adapters, for the CN-8032-L, if you want to form a ring network,
we must lead a industry switch.
Yes, we need to have switches with the ring network functions to support for the ODOT CN-8032-L to form the ring network. Please make sure to inquire us before you start the purchasing by scanning our QR code or email.
You can email us through sales@odotautomation.com.
Yes. Also, after visiting this video, will be only appreciated if you can send us any feedback or suggestions to us. With your suggestions, we will help. It will help us to improve our services or products. Thank you.
Thank you for watching.
Okay, we can please also keep some following on our websites or focusing on our LinkedIn or any updatings on YouTube. We will keep some updating with more useful videos with our IO solutions. Okay, we will see you next time. Thanks for watching our live today. Thank you. Bye.
Bye.